It's my pleasure to introduce to you the last speaker, not the latest, also the latest, speaker of the day and of the entire conference, actually, Denis Shabalin. He's a PhD student at, can you guess which university? I'm taking guesses. Which one? Chicago, exactly. He has a very impressive GitHub, I have to say. He is the author of Scala Native, which I personally find awesome, and Scala Offheap, which is perhaps less well known, but not less awesome. It's a way to manage memory outside of the Java GC. But anyway, I think it's awesome. And his activity chart on GitHub is actually so dense that you can see exactly when he went on vacation, which was it 7th of August to the 1st of September?
Right.
Yeah, see, well. And I saw that there was one commit on the 21st of August. There was cheeky pull request merge.
Yeah.
What happened? What were you doing?
I have no idea.
No?
It just happened.
You were just like, fuck, I gotta get my fix. Get a little well.
Exactly.
So this guy is full on coder. This guy's good. This guy's real. So without further ado, please give a very warm and hearty applause for Denis Shabalin.
So as you've just heard, I'm currently working on this thing called Scala Native, and it's awesome, and it's my kind of day job to do research in that area, but I'm not going to talk about it today. So for once, I decided to give a talk about something fun for me, something fun as I just discovered on my vacation, and you just heard the dates. It was somewhere there. Oh my God, don't you sleep on me. Okay, so today I'm going to talk about this area of software developments, which is basically design patterns of how you write your code, and different title for the same talk might be "Try Finally Considered Harmful." I wasn't quite sure which one to pick, so I decided to go with both. And the reason why I want to talk about this is because resource management is generally an area that just about everybody gets wrong. And when I mean everybody, I mean I only knew a few cases where it's actually so true. One of those cases is akka, and be prepared. It's a bit hard to see, but it's a bit scary. Yeah. So this nice try finally chain is a piece of akka that does clean up to destroy actors after they're done. And as you can see, it's actually quite involved. You have try that does something simple, and then you have finally, in a finally, in a finally, in a finally. And there is a comment that says, the following order is crucial for things to work properly. Only change this if you're very confident and lucky. And this is basically a state of correct resource management in Scala right now. Yeah, it's a bit sad. So essentially, I was talking about resource management. What's a resource? So resource is a thing that has essentially two actions that you can always do to it. The first one is acquire, and the other one is release. So when you acquire resources, you get access to the things that you want to use. For example, it can be opening a file, network connection, allocating memory, or whatnot. And releasing is doing the inverse. It's you giving it back. The time between the two, the acquire and release, is something called resource lifetime. And you really, really seriously, you want to minimize this time to the minimum. So some of the examples of resources that people deal with on day-to-day basis are file handles. So in Java terms, those are different buffers and writers and readers and so on and so forth. Network connections, like TCP connections, locks, of heap memory allocations, thread pools, actor systems, or maybe even OpenGL contexts. So, as you probably might have noticed, like the common theme behind all of them is those are heavy things. You don't want to lose an actor system by accident, you know. You really have to be sure that it's cleaned up once you're done with it, and you really want to clean it up as soon as possible. And this is kind of hard in the presence of exceptions, and as we've seen before, it's actually very hard. So people actually came up with all of these different patterns to survive and somehow get through and manage their stuff. So the first kind of pattern, which is not really a pattern, but what people do when they have nothing else to do, is manual resource management. And it's available in every single language you can possibly imagine. But the only language where it's acceptable is C, because you don't really have much choice in C. That's all you have, essentially. So a simple example of code can be seen here. So we have a function main that just opens a file, does something interesting with it. We're opening it in write mode, so probably we're going to write some stuff in here. And then we close it in the end. So C is a very simple language. There are no exceptions or anything funny, so we can reasonably assume that close will actually happen, unless something completely weird like a sec fault happens over here. So this weird arrow on the right denotes my comment that illustrates the lifetime of the resource. And that's the interesting part. So that's essentially the piece of code that I highlighted is your file handle will be live from open to close, and you really want to close as soon as possible. In Java, the same code the same code will look slightly different because you also need to account for exceptions. So you actually need to wrap it into try finally. And until Java 7, it was actually the only way to do stuff. So it was kind of hard. So another solution to the same problem as seen is in C++, D, and Rust, and many, many other languages probably, but those are the famous three, is that the pattern of RAI, or resource acquisition, is initialization. The main idea of this pattern is that you wrap your resource into a safe wrapper. The goal of safe wrapper is to ensure that your resource is always cleaned up. And the way you do it, you acquire everything you need in a constructor over here. So here we open a file, C file, is a simple way. And in the structure over here, we clean it up. And we encapsulate state privately so that nobody can see it. And the way it looks in code is that now your lifetime is bound by the scope where you allocated the thing. So here, for example, we allocate thing on the static scope of the on the stack of a function, and as soon as we call ends, it's automatically cleaned up. So compiler inserts a destruction call because we are done with f. And really nice thing about it is that because it's done automatically for you, you don't need to worry about closing things. So you can just open them, and you will know for sure that they'll be cleaned up. Another pattern which is probably existed before in C++ and D, but people only really noticed it in Go, is scope guards. So scope guards is a pattern where you say, so I do an open now, but I want to do a close later. But it's really hard to manage all these weird scopes, as in like with try finally. So it's actually way easier to just smash the two together. So you say, every time you open, you close at the same place, but you cannot close immediately, so you need to defer the computation until later time. So essentially, it's still kind of manual because you can still forget to defer closing, right? But it's kind of nice. So yeah, there is that. And then we have using that, if I'm not mistaken, was originally introduced in C# and then picked up by a bunch of other languages like Java. So in Java, now we have, in modern Java, we have something called try with resources, And this one lets you scope resources with the help of this nice syntax. It says try, assignment, and then block. So basically, we get the same nice lifetime as with other solutions, but the thing is we don't need to close it because it's done for us, but it's still not that safe because there's nothing that prevents us from constructing a print writer and never closing it or not using try with resources at all. And of course, then we have the M word, right? Every solution has a solution with the help of M word. And I guess if all you have is a purely functional language, then every single thing looks like a monad because the world, is not pure. And Scala is no exception. We have a nice monadic solution called Scala ARM. It's a library by Josh, and essentially what it lets you do is it abuses for comprehension to express the same thing as we've seen before with try with resources. Unlike try with resources, it's quite a bit more powerful because managed of expression gives you a resource of t. So it's a bit more high level and it's less ad hoc as in Java because you might potentially have fun combining it with other monads like, try, future, and options, and then just have all the fun with monad transformers in the world, all the good stuff. But really Scala is not a pure language, and you would really want and at least hope that there is some alternative solution, because right now we are, as a community, that's all we've got. So we have manual management in Scala, and we have Scala ARM. That's essentially the whole story. And obviously right now this is the best choice Scala community has. But really, we don't really need monads to solve such a simple problem. All we need is to just close the damn thing once it's done. It's not too hard. It's not supposed to require you to have such a high-level concept, right? So, but all of these nice solutions like monads and stuff, what do people actually write in their actual code, right? And what happens in real life is that people don't really care. They just open their files and whatnot and then just don't close them. And luckily we are on JVM, so we have a nice safety of being automatically closed on finalizer. But in a sense, this question mark here means this resource can leave really long. So if you don't have GC, if you don't cause GC pressure, this question mark can essentially make you over-acquire large pools of resources like files, which will hit your open file limits and stuff like that. So it's not really a solution, and people should really stop doing that. And the main reason why people are doing that is that it compiles, it runs, and we can just ship it, and it works for some time, right? So that's basically the nice thing that people do because it's not too bad. But what's even more fun is when people use implicits and pass all of their resources as implicits around. And Daniel Spivak recently just noticed that it's really fun. Random Scala anti-pattern encoding resource cycles through implicits. It's obviously an anti-pattern for handling resources like files and stuff, because those need to be carefully kept away and disposed carefully, right? You don't want to accidentally leak them all over the place. But at the same time, he says encoding resource life cycles through implicits is a bad idea, but it's actually not. It's actually the opposite. Implicits are, in a sense, a perfect tool to encode lifetimes. They're just not a nice tool to pass around resources. So basically what you need is a proper encoding of a lifetime that is not a resource itself. So, in perfect world, we would have some kind of magic solution that lets us have safe writers which automatically close once they're done with. But this unicorn world where everything is nice, there is no war and humanity has conquered all their problems, right? But getting more real, we can still get pretty damn close if we just introduce a very simple concept. And this concept is called scope, and what scope is essentially a reified version of a lifetime. So it's a first-class lifetime that you can touch and feel. And to write libraries with the help of this, all you need is a very simple thing. You just put all of your resources into scopes, which sounds kind of stupid, right? You're already doing that. But scopes will remember everything, and they'll make sure that everything is disposed safely. They're like a black hole that consumes everything and makes you not worry about things. And really, scope is just a delayed promise that someone will clean your stuff up. So now, if we want to write a safe code equivalent of print writer, we would make something called safe writer, right? Which makes sense. It's a print writer like sane, but acquired and released safely. So the main difference, we encapsulate our writer in a class called safe writer, and this class requires an implicit scope, which basically means there is some place that will definitely clean this mess up. And we acquire we bind resource to a scope with this acquire magic thingy, which links to together and makes us not worry about it. And now, a nice thing that happens is because we used implicits to model lifetimes, is that we actually don't need to worry about lifetimes anymore because compiler will help us. So now, if by chance of accident we don't have any lifetime in scope to safely dispose of a safe writer, compiler will actually tell us. That's really nice. So you'll just say something nice like resource acquisition requires a scope. You need to put it somewhere. You cannot just mindlessly do it anymore. And it gets even better in Dotty because in Dotty there's a plan to introduce new features which is called implicit functions, and they remove all of the boilerplate that we've seen before over here. So basically, this overhead is completely unnecessary, and it gets us essentially to a place where we are just one word away from our perfect solution. So the only thing that changed from before is that now we say scope block and not just block. And just prove how easy it is, I will just code this thing up, like right here. Okay, that's not what I wanted. So essentially, it's actually very, very simple. It's really simple. That's why I like it. So we have an application, right? My app extends app. And we would like to do something simple, like we would like to write a message to a file, for example. So we say val writer equals new Java IO print writer. Yeah. Better? Yep. Print writer, right? Okay. Then we write our message. We want schedules. And we close it, right? And that would be a very naive thing to do because it's actually not correct, right? As you can see, writer.write can throw. So what you just did is actually we've just accidentally licked a resource because no one will ever close it if it's somewhere in the middle of a large code base. So a proper manual Scala like today would require you to try finally and just say writer.close here. And this is fine. This is what you can do today, and that's. But the main issue is like this will not compose further because as we need to do more complicated things, this try finally chain will become a huge monster, as we've seen in Akka. So instead, what we want to do, we want to hide away all of the unsafe stuff and make it safe. So we want to do a safe writer. A safe writer is just the same as a normal writer, only it will not shoot you in the foot. So it contains a writer, of course, internally. We cannot get out of there. Takes a pass, for example. That's not hardcore everything. And it takes a scope. So scope is the thing that makes things safe, because you know that it will be eventually cleaned up. So we have write, string, unit, writer.write, message again. Okay, but before we go there, so a simple solution, quote unquote, don't do this ever, is to just define a finalizer and really protect it override def probably. Finalize. And just close it there, right? Because it will totally clean everything up for us. But it will not, because GC, there is zero guarantee when it will happen, and you have no idea actually. So it might happen sooner, it might happen later, it might happen too late. And it always does. So this is like what another common thing that people do is they just define finalizers and are absolutely happy with how everything is eventually cleaned up, but it doesn't always work, unfortunately. So we need to do scopes. We have to. So what's the scope, right? I have not talked much about it, so it's obviously a type, right? We use it in type position. And you can acquire things in scopes. So you can say in.acquire in scope. Okay. Resource. So a resource, we could probably define our own trait for that, but for sake of compatibility with Java, it's actually all we need is just a trait with a single message. So we might as well just use Java closable, or better, auto-closable. Okay, so we have scopes. We can acquire stuff in scopes. And we can close and open them, of course. So next thing we need to do, we need to open a scope. So scope is opened by passing a closure. It gives you a scope. So we have a function from whatever to whatever. So from scope to unit. And we'll give you t. From scope to t, and we'll give you t. Okay, so does it compile? Keep writer close. What? Okay. Acquire does not return units. That's a mistake. Just I will. Better not found, but what's wrong then? Why don't you go up? Okay. I'm trying to quit the thing, and it's as always, it's too hard. Okay. Yeah. Sometimes it never quits, and I just stay there, like, just wondering what I'm doing with my life. Need finalizer, and we need acquire to return a resource, and not just resource, but the same thing. Okay, that's better. Okay, that's good. So now it compiles, right? So we can just ship it. So that's good enough. But yeah, question marks are looking at us, so we need to address those. So first of all, the scope is a simple thing, so you just make a new scope. So if you want to, of course, you can make scopes on your own, and then you can do stuff in funny ways. Like, for example, you can tie scopes to async computations that thread through multiple features and fun stuff like that, but we're not going to talk about it. So we try to evaluate f, and finally we close our scope. Okay. So to close the scope, so when we acquire a resource, we need to remember things somewhere. So we'll use a simple mutable state in here, but I'm reasonably certain that there is a purely functional equivalent, but for sake of simplicity, we're just going to use a bit of mutable state over here. So acquiring is just pushing things onto the stack and getting them back. So closing is actually a bit more interesting, because now to implement close, we need to remember the fact that, so a simple thing to do would be to say stack for each close and then clean up the stack. But that's actually not correct, because every single close of every single resource on a stack needs to be exception safe. I mean, it can throw, so we need to be able to make sure that it still works, right? So what we do, we actually need to make a recursive function. So in case we have no resources, we have nothing to do, right? In case we have something, so the first thing we do is we do a bit of side effects. Right, that's fine. Try. And here we close the head, right? So head is a resource, so we need to clean it up. And then finally we continue with our life, right? We just close everything else. And this actually gives us equivalent of that long try finally chain only in a first class way, because stack of resources is actually a value, right? We can actually handle it in a first class way. So we traverse it recursively and we close everything, right? In a following way, right? So that's probably it. Yeah?
Resource should be stacked
In close, resource should be stacked. Yeah, that's correct. It's not a member of time parameter. Okay. Does it work? So now let's side effect some more to see that it works, right? Acquire path. And here what also we can do is we can make a safe writer a resource itself, so that we can see, we can observe the fact that it's been closed. And that's actually super easy. We just make it a resource and implement close. Close will still not do anything interesting. It will just clean up our writer. But now we can also observe the closing. And now, instead of acquiring a print variable, we can acquire it ourselves, right? Which is kind of deep, but I'm not sure. Yeah. Okay. Okay, good. So we're acquiring and releasing, and now, so let's see how the simple thing scales, right? So first of all, what happens when we need to acquire more stuff? So we put more stuff here, And scope actually happens just once, so we have a really, really low price to pay if we do more than one thing. And also, unwinds everything in correct order. We want schedules, seriously. Okay. So as you see, same file. Let's make a different file. Yeah, I think it's fine. So, the main point is we have two writers. We write to two files, and the interesting point is what's the order. And we actually want to put everything on stack and then unwrite back. So we put stuff and take them back in reverse order, so it's fine. And now let's play with exceptions, right? So what happens if we just insert exceptions randomly to simulate the real life conditions, right? No. So here we just acquired one resource, so let's acquire two. So it will crash, of course. But the thing is, we don't need to worry about the cleanup anymore because it's done automatically behind the scenes. And really, we can insert this thing anywhere and it will still work. It's really impressive. So you see, this code is actually super simple. And at the same time, it's absolutely safe in terms of exception handling. So it doesn't really get in the way, and it really is a very simple idea. So all of our implementation fits in one screen, essentially. So we have a final class scope, and we have, basically that's it. Huh? So it's one screen of code, very simple thing, very easy to use. You don't need a library to use it. And it actually is very nice. Yeah. Okay.
Quick question.
Yeah.
What happens if I try to nest scopes?
That's fine. I mean, scopes actually, I forgot to do this, but so the first thing, if you want to push this idea further, is you can say that scopes is a resource, right? It has a close method, after all. And what you can imagine doing is, first of all, if you don't care about a fine-grained resource management, you can actually construct trees of scopes. You can construct one fat scope for everything. You're really kind of free to do whatever you want. And it really composes quite nicely. Because so essentially every time you say scope, you create a new lifetime in a specific place. And you can make as many of those as possible. And as I've said before, you can also say a new scope explicitly to do something funny, like thread a single lifetime through a number of futures, which can correspond to some processing in async system, right?
So I think if you nest those scope blocks, aren't you going to see ambiguities for the implicit?
Yeah, stuff like that might happen. So then you just name it the same way, right? And then it works, as far as I remember. Yeah, well, yeah. Yeah, it's fine. But as your point, it's an issue, but I would say it's a language issue that we should probably discuss separately. It's not a part of the specific idea, but it's part of how.
How does it get on with Dotty? Because in Dotty, presumably you don't have any choice about the name.
Yeah, so with Dotty, you don't get choice about name, so you would write something like this, right, and it will work. And if you want to.
In Dotty, the names like these are always shadows?
As far as I understand, they're always shadow, yes. And if you, in Dotty, if you want to have an explicit thing, you will just say in1 equals implicitly of scope, right? And you can have it, and you can pass around it explicitly, or you can make it a function parameter after all. It's really, really simple, and it actually scales quite nicely, and it requires zero syncing after you wrap your stuff in safe wrappers, because at this point you're, actually, let's check that out. So what happens if you now try to make a writer without a scope, right? Get a nice exception, could not find implicit value for parameter scope. But for that, we can also make it even nicer by saying annotation, implicit not found, right? Resource acquisition requires a scope. Yeah, that's nice. Nice and clear. Okay, so now if you have internet, I'm just gonna twist this stuff up because it's really cool in my opinion. No internet, okay. I'll do it a bit later. So really a single takeaway that I would like, if you completely skipped all that coding mess and you just want to get something from this talk to remember about resource management, and it's that. Get your stuff together, get it all together and put it in a backpack. All your stuff so it's together. And if you gotta take it somewhere, you know, take it to the stuff store and sell it or put it in a stuff museum. I don't really care what you do, just gonna get it together. No, seriously, get your stuff together. Okay, thanks.